These are the solutions for the Algebra 2 Chapter 11 or Unit 9 test. For problems 1 through 4, we're going to consider the sequence 54, 52, 50, 48. You can see the numbers are going down by 2 each time, so our constant difference here is going to be -2. We're going to use that in a few places in your formula. For number 1, when you write a recursive formula should always start with what the first term is, which in this case is 54. And then a formula to find any term. You remember we abbreviated any term with the abbreviation a sub n. To find any term, what we do is we take the previous term, which we call a sub n minus 1, and we subtract 2. So your formula should consist of two things. A sub 1 equals 54, and a sub n equals a sub n minus 1 minus 2. To get to any term, take the previous term minus 2. Obviously, the next 4 terms in the sequence can be found by subtracting 2, which gives you 46, 44, 42, and 40. For the explicit formula for an arithmetic sequence, what we're going to use is this formula I'm bringing up right here, the a sub n equals a sub 1 plus n minus 1 times d formula. This is the explicit formula for an arithmetic sequence, and we're going to plug values into this formula to get a formula here. What we do know in this formula is we do know the first term, a sub 1, that's 54. We also know the constant difference, which is -2. Because it's a negative, you do need to put it inside parentheses. Otherwise, it looks like you're just subtracting 2. We want to make sure it's clear you're multiplying by -2. If you leave the formula like that, that's fine. I will accept this for full credit. However, if you want to take it a little further, what you can do is you can multiply both of these terms inside the first set of parentheses by -2. So you'd get 54. -2 times n is -2n. -2 times -1 is +2. And then you could simplify this further by adding 54 and 2, which is 56, and getting -2n plus 56. I'm okay with this answer or this answer. Both are fine. To find the 20th term in the sequence, if we take the last formula we came up with, which is -2n plus 56, and plug in 20 for n, you get 2 times -2 times 20 plus 56. This is -40 plus 56, which equals 16. I suppose what you could also do is just continue counting by 2's until you get to 20 terms. So if you use all your fingers and toes and you start at 54, you'll eventually get down to 16. On problems 5 through 7, consider the sequence 8, 12, 18, 27. It's pretty clear this is not an arithmetic sequence because these numbers go up by 4 and then 6 and then 9. So it's definitely not an arithmetic sequence. To see if it's a geometric sequence, you can take any term and divide it by the previous term. So if you take 12 and divide it by 8, you get 1.5. That's your constant ratio. That works if you do 18 divided by 12 or 27 divided by 18. Any term divided by the previous term gives you the same constant ratio. So we know that this is a geometric sequence because we're going up by a multiplication factor of 1.5. For number 5, we're trying to find a recursive formula just like we did in problem number 1. When you do a recursive formula, there are going to be 2 steps. The first step is writing down what the first term is, which is 8. And then to find any term, you take the previous term, and this time you multiply by 1.5, your constant ratio. So to find any term, remember a sub n means any term, you take the previous term, and then we're going to multiply by 1.5. The explicit formula we're going to use is the explicit formula for a geometric sequence, which is the second formula on your formula sheet. A sub n equals a sub 1 times r to the n minus 1 power. This will be the formula we plug values into. In this situation, a sub 1 is equal to the first term, which is 8. The constant ratio is 1.5. Your exponent stays as n minus 1, and that is your explicit formula right here. To find the 20th term of the sequence, you can plug in 20 for n. So you're finding a sub 20, the 20th term, which is 8 times 1.5 to the 20 minus 1 power. Type this in your calculator. The only thing I would suggest doing here is when you type this in, make sure that the exponent is in parentheses, otherwise you won't get the right answer. The right answer is a big number. It's also a decimal that's been rounded. It's approximately 17,734.70256. If you rounded this number, that's fine. For 8 and 9, you're writing the sequence in summation notation. It's actually a series because we're adding this group of numbers together. Summation notation means we're going to use the Greek letter sigma. You can always start with n equals 1 on the bottom. So anytime it says rewrite the series, you can start with n equals 1 for this unit. The number of terms you're adding together goes on the top. Here we're adding 1, 2, 3, 4 terms. That goes here. It appears that we're adding 4 terms here, but then there's a plus dot dot dot, which means we're adding basically an infinite series together. So we're going to write infinity here because we're writing an infinite number of numbers that we're going to add together. What we put on the right side is the formula for the explicit formula for that sequence. Now number 8, this is a sequence of numbers that's going down by 2s. In fact, it's the same group of numbers that we have here. So what we do is we write down the explicit formula. I'm going to use this one. You could use this one right here as well. Doesn't matter. I'm going to take the right side of this explicit formula, and that goes here, negative 2n plus 56. You must put the explicit formula in parentheses. So what we write for this problem is a summation notation, n equals 1, number of terms on top. The explicit formula for that type of series goes on the right side. For number 9, same idea. The explicit formula here, we have 8, 12, 18, 27. You may remember that's the formula that we worked with here on problems 5 through 7. The right side of the explicit formula is right there. So we do 8 times 1.5 to the n minus 1 power. We'll put that in parentheses as well. So what goes on the right side of the sigma notation is the explicit formula for that type of sequence. On your retake, if you decide to do a retake, just make sure it's going to look something like either this, which we simplified to get negative 2n plus 56, or it's going to look like this, which you see here, depending on if it's arithmetic or geometric. Let's go to the next page. Problem 10, find the sum of the first 80 odd numbers using an arithmetic series formula. Well, the arithmetic series formula is this third formula here. It's n over 2 times a sub 1 plus a sub n. To use this formula, we need to know how many terms we're adding together. In this case, it's 80, so that's what n is equal to. We need to know the first term, a sub 1. That's the first number here, which is 1. We need to know a sub n, the last term. Well, the last term is at 5. There's supposedly 80 numbers we're adding together. And if you don't know what this number is, it is a sub n, and we do have a formula, if it's an arithmetic sequence, to find a sub n. Now, there's 2 formulas for a sub n. The first one's for arithmetic. The second one's for a geometric sequence. Because we're working with an arithmetic problem, we want to make sure that we're using this top formula. So I'm going to use this top formula here to figure out what a sub n is. Once I know that, I can plug it in here and get my answer. So a sub n is equal to our formula a sub 1 plus n minus 1 times d. A sub 1 is the first term, which is 1. I'm looking for the 80th term, so I'm going to plug in 80 for n. Constant difference is 2. If you crunch this value out, you get 1 plus 79 times 2, which is 1 plus 158, or 159. So the 80th odd number is 159. And if you do 80 over 2, 1 plus 159 in parentheses, you multiply this out, this actually ends up being 40 times 160, or 6,400. And that's your solution. On number 11, you're also finding a sum, but you're going to use a geometric series formula. And the geometric series formula is this fourth one here. It's s sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r. In this problem, we know the first term is 1. The ratio, if you aren't sure, you can divide any term by the previous term. So if you do 2 over 1, or 4 over 2, or even 8 over 4, you get 2. That's your constant ratio. So we're going to do 1 minus 2, n is the number of terms, 10, over 1 minus r. If you type this in your calculator, make sure the denominator is in parentheses. If you do that, you should get 1,023. To solve 12 through 15, we're going to find the sum of infinite geometric series, which means we're going to use this formula here, s equals a sub 1 over 1 minus r. Remember, you can only use this formula if the absolute value of r is less than 1, which also means that r has to be between negative 1 and positive 1. On number 12, this number in parentheses is actually the ratio. It's too big. That means you can't use the formula, and we say the series diverges. If you aren't sure and you're like, oh, I want to make sure about this, what you can do is you can plug in 1 for n and 2 for n and calculate the ratio. So if you actually calculate 1, if you plug 1 in for n in this problem, you get an exponent of 0. You get 6 times 1.1 to the 0 power, which is 6 times 1, or just 6. To find the second term, you do 6 times 1.1 to the 2 minus 1 power, which is 6 times 1.1 to the first, or just 6 times 1.1, which is 6.6. If you divide these two terms, you get your ratio of 1.1. It's too big. The series diverges because r is not between -1 and 1. For 13, to find r, we're going to take any term divided by the previous term. I just did 27 divided by 54, which is 0.5. You can divide any term by the previous term, and it's half. So because the ratio is between -1 and 1, we can use our series formula, a sub 1 over 1 minus r. First term is 54. We do 1 minus 0.5 down here. Again, if you type it in your calculator, put this in parentheses. When you divide these numbers, you get 108. That's what the sum would add up to. On 14, r is equal to -27 over 54, which is -0.5. It's kind of the same group of numbers, except the signs alternate between positives and negatives. So your r value is -0.5. That's still between -1 and 1, so we can still use the same formula. A lot of the same numbers, except this time we do 1 minus -0.5. So you're going to have to put the -0.5 in parentheses as well as the whole denominator. When you crunch that out, you get 36. On 15, the ratio is equal to 13.5 over 6.75. That's equal to 2. 2 is too big. These numbers are getting bigger and bigger, which means that when you add the numbers together, you're going to head out toward infinity. This series diverges. To solve number 16, what we do is we substitute 3 into the equation for n, then we substitute 4 into the equation for n, then we substitute 5, and then we substitute 6. And we're going to crunch out each of these 4 values. And then we're going to add them together because it's a summation. So what you end up with is 3 minus 12, 3 minus 16, 3 minus 20, and 3 minus 24. If you want to crunch out these 4 values individually, that would give you -9, -13, -17, and -21. And when you add these 4 numbers together, you get -60 for your answer. On 17, you're saving $3,000 during your first year of work. Every year thereafter, you save $2,000 more. So the next year, you'll save a total of $5,000. The next year, $7,000. The next year, $9,000 for 30 years. If you retire after year 30, how much money have you saved for retirement? Well, what we're going to do is we're going to add these numbers together. This is an arithmetic sequence because the numbers are going up by 2,000s. So we will use the S sub n equals n over 2 times a sub 1 plus a sub n formula. We're looking at a series of 30 years, so n is equal to 30. The first year is 3,000. We know that. Again, I don't know what a sub n is equal to, so similar to problem number 10, what we're going to do is to find a sub n, we're going to use our arithmetic sequence formula and figure out how much money was saved during the 30th year. A sub 1 in this problem is 3,000. I'm looking for the 30th term, so 30 is our value for n. D is what the numbers are going up by, which is 2,000. If you simplify this, you're going to get 3,000 plus 29 times 2,000. That's equal to 3,000 plus 58,000, which equals 61,000. So that's how much money you make during the 30th year of your working. You've actually saved 61,000 during that year. That's a lot of money to save for 1 year. And if you plug that in for a sub n, crunch this out, you get 30 over 2, which equals 15. 3,000 plus 61,000 is 64,000. And when you multiply these two numbers together, you get $960,000. And that's how much you save for retirement based on this formula. And those are your answers for your test.